Greetings, humans. This is fourth grade lesson 6-9. We are measuring more angles. Congratulations, we're doing more angle stuff. I'm on page 213, and this lesson comes with a catch. You kind of need a protractor to do it super accurately. A protractor is this guy here. But if you don't have a protractor, it can still work. It'll just take a little more thought, I guess. So why don't we go ahead and dive in, and we'll talk about what we're looking for here. Sorry about that. Cat wanted to come in, but I opened the door and now she doesn't want to come in. Classic cat stuff. Anyway, let's look at our directions. It says identify each angle as acute, right, straight, or obtuse. Okay, so you guys are pretty familiar with three of those terms at least. I'm going to throw this up top in case you didn't get a chance to take your math folder home. We know an acute angle, just as a review, is less than 90 degrees. And we know a right angle is what? As I'm writing this, think about what a right angle is. Exactly 90 degrees. And if you need a refresher for what exactly 90 degrees looks like, it looks like a letter L, capital L, and sometimes they will tell you it's 90 degrees by putting in a little square on the inside. That's basically their way of saying, yes, this is a perfect 90 degrees. Just keep in mind that a 90-degree angle can also be crooked as long as it's still technically an L shape. You might have to twist to see that perfect L. But this would still qualify as pretty much 90 degrees. Okay, so acute, less than that, smaller. A right angle is exactly that. Obtuse, if an acute is less than 90, then obtuse is more than 90 degrees. So an example would be, these are the ones that tend to look a little bit wider. This is just an example here. So it's something that's more than 90. Maybe I'll go back up top here and also add an example of an acute. Those are going to be your smaller, less than 90s. We're going to add a new one today. It's a straight angle. Don't worry about this one too much because watch what it is. I bet you can already guess. It's a perfect line. It still has a vertex. It still has a midpoint here, like a point. Here's the vertex. 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 The vertex is where two lines meet. A straight angle still has a vertex. But it is going to be exactly 180 degrees. So basically like two right angles, it's going to form a straight line. I'm going to add a bonus one. We talked about this one a few lessons ago. It's called a flex angle, and that is more than 180 degrees. And the only way you can really tell a flex angle is a flex angle is on account of the rotation. Sometimes it's confusing. For instance, this can look like an acute angle at first, but if the rotation actually went this way, do you notice how that rotation was more than 90 degrees and more than 180 degrees? We're not going to worry too much about a flex angle today, but it is something that I wanted to put on your mind. Of course, in the true acute, the rotation is just this tiny little movement, where in a flex, I'm off the screen. Sorry, guys. A flex is when you go all the way around, basically in the other direction here. Okay, so we're going to focus on, I'd say, these guys today. So let's get back to it. Come back over and let me identify that 180 degrees right on the dot. Okay, so we're going to identify each angle and then we're going to measure them. So maybe what I'll do for my people who don't have protractors, because I'm going to be real with you, there's probably a lot of houses that don't have protractors lying around. There's not a whole lot of use at home for them these days. So for the people who don't have protractors, we can at least do this. We can identify the type of each angle. For instance, if you look at A, we can ask ourselves, is this guy a right angle? And you may notice what I did here, by the way, a strategy. I like to try to get this bottom line straight to me. Do you notice how he looks like a straight line now? Because that helps me identify the angle a little better than if I'm looking at like a letter V. Sorry, hit my lamp. So I like to make him look straight, just like this. So now the question is, do we have a right angle? Do we have a perfect L? No, so he's not a right angle. Next question, is he a straight angle? Does it just go straight across? No. So we've eliminated two of our options. That means this angle is either obtuse or acute. An acute angle, remember like a little acute angle, will be less than 90 degrees. So here's where 90 should be. Here's that L shape. So tell me, is this angle smaller than 90 degrees? You bet. So that means A would be an acute angle. So I'm going to put this task to you guys. I'm not going to walk through any other types. That's an idea of what they're looking for. So for B, you're going to want to do the same thing. Straighten them up to your face so you can see that bottom line and he's straight to you. Same with C. And then this is what's going to help you kind of conclude and see what type of angles you have. If you need to, you can go back in the video, freeze it on the definitions that I wrote on the notebook, and that could give you a little extra help. Of course, Google will also give you some real quick definitions of each type of angle. Now, regarding the measurements, I'll give you the protractor way first. Okay, I'll give you a refresher. And then I'll talk about the logic we can use if you don't have a protractor. So if you have a protractor, I'm going to use C as our example. You want to take, this will be review for you guys, but it's easy to forget over time. So you need to find the hole in the middle of the protractor. Most will have holes. If they don't, you'll have to use the bottom middle. You're going to put that hole right over the vertex. Remember, the vertex is where the two lines meet. There's usually a dot there. So put that hole right over the vertex. And you see these black lines right here? You want these to be right on top of this bottom line. So it almost looks like you can't even see a line there. So you have the hole in the vertex, and you have that black line lined up with the actual line of the angle. And now you should see we have 0 degrees right here. We start from 0. And we're going to use the inside numbers from the right side. If you start from over here, you start on the outside. But starting from over here where our angle was pointed, we're starting from 0. We can see it goes 10, 20, 30, 40, 50, 60, 70, 80. Here's the 90 degrees. And are we over 90 degrees? Yes, we are. 100. 110, 120, and if you want to get really specific, this arrow is over 120, but he's not quite to 130. In fact, you kind of have to extend him out a little bit. He doesn't even look like he's at 125 quite yet. These little individual marks up here each count as 1. So to me, this looks like he's pointing at just about 123 degrees. Here's 120. It looks like 121, 122, and it looks like he's pointing at just about right here, which would be 123 degrees. That's going to be a pretty exact answer. So what you'll do, I'm looking at C now, and watch. You guys may have already seen this, but C is not asking for an exact. It's the one answer where they're looking for a between. And we actually said we finished up at 123. So that's going to be between, you can either say between 120 and 125, or you can say between 120 and 130. For me, I'm going to try to be as exact as I can go with this between part. I'm going to say he was between 120 and 125. And again, we got the exact answer, but they just want the estimate for that. So that's how you use a protractor. If you don't have a protractor, I'm going to be a little bit more lenient on your angle measurements. And here's what you're going to have to do. First, you have to be patient with me. But in order to find these estimates without a protractor, we're going to have to find some milestones that we can use. For instance, we know for a fact, or almost as a fact, that this L shape is how many degrees. We know a right angle, or what appears to be a right angle, would be exactly 90 degrees. So ask yourself, if you look at A, is A 90 degrees? We know it's not. We already figured that out. Does he look like he's about half the size of 90? And to that I say, maybe. Okay, this is where your number sense is going to come in. This angle looks to be about half the size. Like if you took two of them, would that add up to 90? Kind of close. Okay, so if we're just estimating, we're looking for round numbers, and he looks almost about half the size of 90, can you find half of 90? Or another way to look at it is, what's 90 divided by 2? Okay, and that will give you an estimate for that angle. Now, we already found out B and C, so the next question would be D, and that comes straight from our definitions. We have a name for this angle. It's on the notebook paper earlier in the lesson, and we already have a degree for this angle. So just a pro tip for that one. And beyond that, you're going to have to ask yourself here, E, here's where 90 degrees would be. Again, that's what I use as my little milestone or my marker. And my question is this angle bigger than 90 or smaller than 90? And to me, he looks bigger. He's not only at 90, but he's going further beyond. So the question is about how much beyond 90 does he appear? And again, it doesn't have to be exact, but we at least know he's above 90, and we know he's going to be not quite however much a straight angle's worth. Okay? And the last one, you're going to be kind of in the same boat. This one's not only smaller than 90, he looks smaller than half of 90 too. So I'm going to be pretty loose with what you do here. The idea is, can you have a broad idea for how much these measurements are worth, what a 90-degree angle is, definitions of acute, right, straight, and obtuse. If you have that stuff mostly in line, then you're going to be in good shape with this lesson. Okay, guys, and just like always, any questions, anything else, email me, dojo me, leave a comment. Otherwise, I'll see you in the next lesson.